So you want to learn how to build apps quickly. You're in the right place. Thanks to the thriving universe of Flutter packages on pub.dev, we can do just that. Today, I'm going to teach you how to build a fully functional shopping list app using Riverpod, Firebase, Hooks, and Freezed. With this combination, we're able to greatly reduce the amount of boilerplate code we have to write when developing apps. If you like my content, remember to like the video and subscribe. As always, you can become a pro member on lunchclub.io for access to all my Flutter courses. And with that, let's get started. We're going to be using null safety in this project, so if null safety isn't available on Flutter stable branch by the time you're watching this video, make sure to switch to the beta channel. You can do this by opening up your terminal and typing flutter channel beta, and then flutter upgrade. Create a new Flutter project, and inside of our pubspec.yaml, the first thing we'll do is add null safety support by changing our Flutter SDK version to 2.12.0-0 and above. Under dependencies, we'll include Firebase Core, Firebase Auth, and Cloud Firestore to interact with Firebase. Next, we have Flutter Hooks and Hooks Riverpod to reduce the amount of code we have to write when consuming providers and creating controllers for widgets like text fields. And finally, for code generation with Freezed, we have to add Freezed annotation to our dependencies. And then under dev dependencies, we need build runner, Freezed, and JSON serializable. Since we're generating code, we don't want our Dart analyzer to lint any generated files. Make a new file called analysisoptions.yaml. And here we can let our analyzer know what files we want to exclude. We want to ignore all files that end with .g.dart and .freeze.dart. Now head over to firebase.google.com to create your Firebase project and link it with your Flutter project. If you need any help with this, you can watch my step-by-step guide. I'll leave a link to the video in the description, or you can tap the card in the top right. In main.dart, we initialized Firebase and wrapped my app in a provider scope to give us the ability to access all of our providers anywhere in the app. Once you finish setting up Firebase and enabling Cloud Firestore, let's go to the Authentication tab. For this project, we're going to use anonymous sign-in and tie each user's shopping list to their account. Let's go back to our Flutter project and work on user authentication. Inside of a new folder called repositories, make a file called auth Let's define an abstract class called base auth repository that contains all the method signatures our auth repository will implement. This is super useful for when it comes time to test our repository because we can easily create a mock auth repository that we know for sure has implemented all of the required methods. We have 4 different method signatures. Auth state changes, which return stream user. User is a class from Firebase Auth that has general user account information. The reason we have a question mark after user is because the value we get from Firebase is null if the user is not logged in. Sign in anonymously creates an anonymous account for our user and logs them in. GetCurrentUser gets and returns the current signed in user, which like before is null if the user is not logged in. Signout logs the current user out. Class auth repository implements base auth repository and takes in a reader from Riverpod. Reader allows the auth repository to read other providers in the app. In this case, we need to read our Firebase auth.instance, which we'll get from a provider called Firebase Auth Provider. We'll define Firebase Auth Provider in a separate file called generalproviders.dart. This provides an instance of Firebase Auth. We're also going to add our Firebase Firestore provider for when we write our item repository to create, read, update, and delete items from Firestore. I'm going to generate all of the methods and reorder them based on how we define them in our base auth repository. For auth state changes, all we have to do is access the Firebase auth.instance with read Firebase auth provider and call the method auth state changes. This method returns a nullable user whenever the current user signs in or signs out. Sign in anonymously is asynchronous, and we just have to await a sign in anonymously to create our user in Firebase. Note that if an anonymous user is already signed in, this method returns the existing anonymous user. GetCurrentUser returns the current user. And signout first logs out the current user and then signs in the user anonymously by calling our sign-in-anonymously method. This ensures that users will always be authenticated while using our app. For error handling, let's wrap each body in a try-catch block and throw a custom exception, passing in the error message from each Firebase auth exception. In a file called customException.dart, we'll make a class called customException that implements exception and contains a string message. Back in Auth Repository.dart, don't forget to provide the auth repository and pass in ref.read so we can access it across our app. To keep track of our user's current authentication state in the app, we're going to create an Auth Controller inside of a Controllers folder. Auth Controller extends a state notifier of type nullable user. This means that the state of our Auth Controller can either be null when the user is not logged in, or a Firebase user when a user is logged in. Auth Controller takes in a reader and has a nullable stream subscription of type nullable user called auth state changes subscription. In the constructor, we set the initial state of our Auth Controller to null because no user is signed in. Then we subscribe to the auth state changes stream from our Auth Repository and update our Auth Controller state whenever a user logs in or logs out. We also need a dispose method to cancel our auth state changes subscription if it exists. And we're only going to have two more methods, appStarted and signout. appStarted gets the current user from Firebase, and if the user is null, then we log the user in with sign in anonymously. Signout calls our Auth Repository's signout method. Let's provide our Auth Controller at the top of this file by using a state notifier provider. We also use cascade notation to call the appStarted method once the Auth Controller is instantiated. This means as soon as the app loads, our user will be authenticated thanks to the appStarted method. To test this, let's run our app and go to main.dart. We're going to add a home screen that extends a hook widget. We can grab the current state of our Auth Controller by using useProvider authControllerProvider.state. Add an app bar with a text title too. When we save this and go to Firebase Authentication, we can see that our first anonymous user was created. We should also test logging out. Our app bar will have an icon button as the leading widget that grabs our Auth Controller provider using context.read and calls signout when pressed. We only want to show the logout button if a user is signed in, so we check if Auth Controller state is not equal to null. When we tap this button and look at Firebase again, we see a new user has been created. Now we're ready to work on our item model. In a new folder called Models, let's make itemmodel.dart. Instead of manually typing out our item class, we can save a lot of time by using freezed to generate our data class with a little bit of boilerplate code. Import freezed annotation and foundation, and write part itemmodel.freeze.dart and part itemmodel.g.dart. These are the two files that will be generated by freezed. The freeze.dart file will contain methods like toString, copyWith, and overrides the double equals operator and hashcode for equality. The g.dart file contains our fromJSON and toJSON methods. We have to define an abstract class with the @freezed annotation above it. Inside of our factory constructor, we have to define the variables of our item. The first one is a nullable ID, which is the ID of our item. This is nullable because when we add our item document to Firestore, it generates an ID for us. We don't need an ID straight off the bat. Our item model will have an ID when we read it back from Firestore. Next, we have a required string name parameter. And lastly, we have bool obtained that defaults to false. In order for our fromJSON and toJSON to generate, we have to add this fromJSON factory constructor. Now we can generate our files by going into our terminal and running flutter packages pub run build _runner watch --delete -conflicting -outputs. When we save, we see that item model freeze.dart and item model.g.dart have been generated. Whenever we make changes to any file utilizing the freeze package, the corresponding files will be updated automatically as long as our terminal command is running in the background. Let's add a couple more factory constructors. Item.empty returns an item with a name and obtained set to false. Item.fromDocument is used for converting document snapshots from Firebase into item models. Because our Firebase document contains a name field and obtained field, we can use the generated fromJSON method to convert our document data into an item. We copy the ID into the model using copyWith, as doc.id is our item ID. We should add a method to convert item models into type mapStringDynamic without the item ID, so we can add them to Firebase. In order to add custom methods to a freeze class, we have to change the with to implements and add a private constructor. Now when we save this, our files are generated correctly. Let's utilize our item model in a new repository called Item Repository.dart. This repository handles all of our CRUD, or create, read, update, delete operations that have to do with items. In Firestore, we'll have a list collection with documents that have the same IDs as our users. Each user document will have another collection called user list, where each document represents an item. I've structured the database in this way purely to demonstrate how we can read and write data to Firestore. Your database schema will change depending on what type of app you're building. Base item repository will have 4 CRUD operations that all require a user ID. Retrieve items returns a future list of items. Create item returns the ID of the created item once it's stored in Firestore. Update item updates the item in Firestore. And delete item deletes the item from the Firestore collection. Just like our auth repository, item repository takes in a reader too. For retrieve items, we get the snapshot at collectionlists.docUserID.collectionUserList and return a map over the documents, converting each one to an item using item.fromDocument. If a Firebase exception is caught, we throw our custom exception. Create item stores the document reference result of adding a new document to the user's user list collection and returns the document ID. Update item is similar to create item, except instead of adding a new document, we update the fields for a specific document using the item's ID and item.toDocument. Delete item goes to the document reference for the specified item and then deletes it. Now if we take a look at all these methods, we repeated the path to the user list collection 4 times. We'll clean this up by creating a new folder called extensions with Firebase Firestore extension.dart. The file will have a single extension method for now, called usersListRef, taking in the user ID and returning the collection reference. Back in item repository, we can import this file and simply swap out each path with usersListRef user ID. This cleans up our code, and the extension file can easily include more paths as the number of Firestore references you need grows. Above this class, let's provide our item repository to the rest of our app. In a file called itemListController.dart, we'll create our itemListController class. itemListController.dart maintains the state of our list of items in the app. When we think about this screen, we know it's going to have 3 different states: loading, data, and error. Loading shows a circular progress indicator, data shows the list of items, and error shows an error message. Luckily, Riverpod has a built-in class called async_value, which includes these 3 states and is meant to be used with futures. We can wrap the list of items in the state notifier with async_value. itemListController takes a reader and nullable user ID. The initial state of the controller will be the loading state, async_value.loading. itemListController needs a user ID in order to perform any operations in Firestore. Let's make our itemListController provider and use ref.watch to constantly listen to the current state of our Auth Controller provider. This will give us the most up-to-date user, whether that's null or an actual Firebase user. We can then pass this into our itemListController's constructor. Our first method is retrieve items that sets the state to async_value.loading if isRefreshing is true, then accesses our item repository provider and calls retrieve items with a user ID. Before setting the state to async_value.data with the list of returned items, I check if mounted is true. Without this check, I was getting an uncaught exception error about itemListController being used after dispose was called. If a custom exception is caught, we return the error state with the custom exception and stack trace. Add item instantiates an item with the passed-in name and obtained values, calls the create item method to add the document to Firestore awaiting the item ID, and then updates the itemListController state. Because we're using async_value, we're able to set the state only when we're in a data state by using state.whenData. We set the state to include the item we just added. Note that we're not wasting any document reads by calling retrieve items. Instead, we add the new item to the existing list of items. In the catch block, we read a provider that hasn't been instantiated yet, called itemListExceptionProvider, and set the state equal to the custom exception. This provider can be declared above our controller provider. The purpose of having a separate provider is so we can listen to this provider in our UI and display error messages using SnackBars. If we just set the state to async_value.error, then users would see a full screen error message. We want users to still be able to view their existing items while notified in a lightweight way that an error occurred. Update item updates the item in Firestore and in our state using a for loop in a list. Delete item removes the item from Firestore and our state by using the remove_where_list method. Now when our item list controller is first instantiated, we want to call retrieve items. In the body of our constructor, we check if user ID is not null and call retrieve items. I'm going to define all the UI in main.dart for this tutorial. Feel free to refactor and separate it out into different files. Let's create a floating action button that calls add_item_dialog.show. We pass in context and an empty item. add_item_dialog is a hook widget with a static show method to display the dialog. It takes in an item and has a boolean getter called isUpdating. We're able to tell if a user is updating an existing item or creating a new one by checking if the item ID is not equal to null. Inside of our build method, we create a text controller using the useTextEditingController hook with the initial text set to the item's name. Return a dialog that has a column with padding and a text field. The column's main axis size is set to main_axis_size.min to constrain the main axis. Add a size box for some padding and an elevated button. The button will be orange if we're updating an item and the primary color if we're not. onPressed also checks if we're updating an item and calls the correct method on item list controller provider. Navigator.ofContext.pop dismisses the dialog. The child is a text widget with either an update or add string. To expand elevated button to the entire width of the dialog, we wrap it in a size box with width set to double.infinity. We want to display a SnackBar whenever there is an exception in our item list controller. The body of our home screen has a provider listener that listens to our item list exception provider. In the onChange, we display a red SnackBar with the custom exceptions error message. The child of our provider listener is a const item list. Item list is a hook widget that uses useProvider to get the current state of our item list controller provider. Item list state is an async value of type list of items, allowing us to use .when to build UI based on the data, loading, and error states. Data returns centered text if the items list is empty, and a list view builder that builds each item. For now, we'll return a container for each item, and come back to this in a moment. Loading returns a centered circular progress indicator, and error returns an item list error with a message. We have to check if the error is a custom exception because the callback gives us error as an object. Item list error is a stateless widget that takes in string message. The build method returns a centered column with text, a sized box, and elevated button that refreshes our item list by calling retrieve items. Let's work on the item tiles our list view builder will return. An item tile is a list tile with a title text, a trailing checkbox, on tap to update item names using the add item dialog, and on long press to delete items. We also need a unique value key to make sure the checkbox animation doesn't rebuild when our list updates. Now this works fine, but we can actually optimize rebuilds of each item in our list by making the item tile constant. To do this, we first need to define something called a scoped provider of type item that throws an unimplemented error. We can now wrap our item tile in a provider scope that overrides the current item scope provider with the current item being built. This means we can extract our item tile into its own widget and access the respective item using that provider. We don't need to pass the item into the widget. Item tile is a hook widget with a constructor. We get the item by writing final item is equal to useProvider current item and return the code we just cut. In our list view builder, the child of our provider scope is const item tile. When we run our app, we see that we can add new items, tap the checkbox to update their obtained value, and long press to delete. We see that the data is updated immediately in Firestore 2. I can also log out and start a new list as a different user. Tapping on a tile allows me to update the name. So this is great. Our app is working as expected. But what if we wanted to be able to filter our items and only view the obtained ones? Thanks to Riverpod, This is pretty easy to do. Inside of our item list controller, let's define an enum named item list filter with two values, all and obtained. Next, we'll make an item list filter provider that uses a state provider to let us know the selected item list filter. We can now create another provider that gives us a list of items based on our current filter and the existing items in our list. We get the current filter and item list state by using ref.watch, so whenever there are changes to the filter or list of items, this provider will return new items. Item list state has .maybe1, so we can return the correct items based on our filter using a switch statement when there is data. If there's no data, we return an empty list. To add this provider to our UI, let's go to our item list and get the filtered item list. We'll set the item count to filtered item list.length, and each item will be taken from the filtered item list. All we have left is to allow users to toggle this filter. Go to the home screen. We'll get the item list filter with useProvider and create a boolean that checks if the current filter is itemlistFilter.obtained. Finally, we'll add an icon button in the app bar's actions that changes the current filter based on whichever one is selected. And that's it. When we toggle the button, we see our items are filtered accordingly. And that's all for this video. I hope you found it helpful in learning more about how we can combine Riverpod, Firebase, Flutter Hooks, and Freezed to build apps faster and with less boilerplate. Remember to leave a like and subscribe, and check out my Flutter courses on my website, launchclub.io, where I teach you how to build popular apps like Instagram. Thanks for watching, and I'll see you in the next one.